Okay, guys, so we are going over the failures of classical mechanics. So, classical mechanics says that if you have a metal surface, any light that hits a surface will be able to eject an electron. And this is not the case. Photoelectric effect sorry guys, really tired, says that you must hit the threshold energy to eject an electron. So there's a minimum amount of energy that the light must have to be able to eject an electron. So we want to get a metal where we don't have to have a high threshold energy. Metals that are more likely to eject electrons are going to be your alkali metals. Okay? These are going to have low threshold energy. They're going to be more likely to eject an electron. So a light with energy at or above threshold will eject an electron. Okay? And that is proven by photoelectric effect. So let's look at this problem. It says potassium metal has a low work function of 2.3 eV. Our work function is the threshold energy needed to eject an electron. So this is the amount of energy we need to eject an electron. Anything less will not eject an electron. Anything less than 2.3 eV. Okay? So because of its location on the periodic table, it has a low work function. Like I said, alkali metals are going to have low work functions, low threshold energies that are needed to eject an electron from their surface. Okay, so moving on. It says contrast what would happen if you had 100 1.5 eV photons hit the surface. So let's draw that out real quick. So we have a metal, which is potassium. Okay, with the work function, which is this little symbol over here, of 2.3 eV. We need 2.3 or greater to eject an electron. The photon needs to have an energy of 2.3 or greater to eject an electron from the potassium surface, from the metal surface. So it says what would happen if we have 100 1.5 eV photons hitting the surface. What would happen? So we're going to go ahead and draw that out. So we're going to have a 1.5 eV, and we're going to have 100 of them. This is a photon, also known as a light, hitting the metal surface. Just because we have 100 of them does not mean anything. We can have 100 of them and we can have one of them. it's still only 1.5 eV. So that 1.5 is not greater than our work function, which is 2.3. So that means that's no electrons will be ejected. Okay? So that 1.5 is not greater than the 2.3, making no electrons be ejected. So it says compared with two 3.0 eV photons. Okay, so now we have a metal, which is potassium still, and our work function is still 2.3. But now we have a 3.0 eV photon hitting the metal surface. 3.0 is greater than 2.3, so we are going to inject an electron. Okay, so it has to be greater than the work function to eject an electron, and it is in this case greater. So we do have some energy left over. Remember, energy is not created nor destroyed. So let's see how much energy we have left over. We had 3 hit the surface, and our minimum amount of energy we need is 2.3 to eject an electron, which we did. So we have 0.7 eV left. What that is going to do, it is going to turn to kinetic energy. And that kinetic energy is going to be added to those electrons that are being ejected. Increasing the velocity of those electrons. So those ejected electrons are now going to go faster because we have leftover energy, which is transformed into kinetic energy.